Welcome everyone. Today we'll be discussing regarding an interesting machine learning project that is factor prediction using machine learning. It is an hybrid feature selection approach where we'll be combining low variance filter and principal component analysis. Without further delay, let's get dive into the project. Here in the very first cell, we are importing few necessary libraries like NumPy and Pandas. They'll be used for data manipulation. Matplotlib and Seaborn, they'll be used for data visualization and various scikit-learn modules. They'll be used for the machine learning tasks. In the next cell, we are importing dataset. I used the dataset from the Kaggle. I'll be giving the link in the description. You can access it. Here we are trying to know about the dataset. The data.head will be printing the first 5 rows in the dataset. As you can see, there are totally 12 columns in the dataset. We'll get to know each of the column in the future. Data.info will talk about the type of column. As you can see, like ID is of integer type or age is of float type. We can see that there are totally 43,400 rows for each of the column, and few columns like smoking status have few null values. Let's handle them in the further. In the next step, we are starting the data pre-processing. As you can see, data.isNull.sum will be giving the total null values in the particular column. Most of the columns here are they are not empty, but there are two columns, BMI and smoking status. They have few empty columns, few empty rows. Let's handle them in further. You can see BMI has totally 3% of missing values. That might not be a big issue, but smoking status has 30% of missing values. So we have to treat it. Before treating the missing values, one thing what I observed is smoking status is an object type. So simply we can't use few techniques like mean, median to fill. So let's first encode it properly. We are using label encoder to encode smoking status. What we'll be doing here is it will be changing these values to 0, 1, and 2 numbers so that we can perform mathematical calculations very easily. After encoding the column smoking status, next we are using one like some complex technique that is decision tree. What we are doing here is since this column has 30% of the missing values, we are using the present 70% values as training data, and we are predicting the 30% values so that the accuracy can be more and we can get the exact values. As you can see now, the missing values in smoking status are 0 and there is no missing values in the smoking status. Using decision tree, we are filling those 30% missing values. And you can see in this step, since BMI is a numerical column and it has only 3% of the missing values, we are filling it with the mean. So wherever there is a missing value, we'll be filling it with the total mean of the BMI column. After doing this step, let's once again verify regarding the null values. As you can see here, after preprocessing BMI and smoking status, there are completely no null values in our dataset. Now let's get further. In this step, we are trying to one-hot encode our column work type. It is very necessary when we are working few of the machine learning models like decision, KNN, decision tree, such kind of things. So what we are doing here is we are one-hot encoding the work type. It will be splitting the work type column based on the total available values in it. In the next step, we are dropping the column ID because we have no use with the column ID in our prediction model. So we are dropping the ID from the dataset. And next step, here comes the most important step in our project. As in, you can see the stroke distribution, which is our target class. It is very high imbalance. It has totally only two values, 0 and 1, where 0 has 42,000 values, but only 1 has only 783 values. So it can lead to severe problems in the future. So we must handle it. So we are using a technique called SMOTE. It is synthetic minority oversampling technique. What we'll be doing here is we'll be taking the minority sample one and we will oversample it so that there will not be any imbalance in the data set. After here it is the code for the SMOTE. After executing SMOTE, we can see the balance, the class is balanced. Both 0 and has the equal data. We can see here the balance is smoke distribution. Now both 0 and 1 has a equal distribution, but previously it is very highly imbalanced. So performing SMOTE is very useful technique for us in this project. Generally, SMOTE will be using KNN algorithm for oversampling the minority class. So since we batch the data set, let's move further. It is also very important to deal with outliers in the data set. If there are if data point has very high range, it can lead to bias and will reduce our accuracy. So we are using IQR method to remove the outliers. Generally, it has our data set has few outliers. It has like in the stroke, in average glucose level, in heart disease. So we are using IQR to cap the outliers so that we'll not get any we'll not get an errors. After handling outliers, we can see most of the outliers were removed. Only average glucose outliers were there. It might not be the big problem for us. In the next step, we are performing normalization where we'll be bringing all the values between 0 to 1 so that the calculations can be easier, the computational cost will be very less, and the predictions can be good. After all this data pre-processing, now once again look into a data.head, which will be returning top 5 rows in our data set. As you can see, now all this data is pre-processed and it is now ready to apply the machine learning algorithms. Now, what we'll be doing here is for this data pre-processed data, we'll be applying totally 5 machine learning algorithms, and then we'll be applying a hybrid feature selection approach where we'll be combining low variance filter and PCA, and then again we'll be applying the machine learning models to most important features which we got from the hybrid feature selection approach, and then we can compare what is the difference by using hybrid feature selection approach and which algorithms are performing well. Now let's start with applying models. I'm directly using scikit-learn for code simplicity. I got few necessary libraries from scikit-learn, as you can see, like KNN, decision tree, logistic regression, and then we are splitting data into train and test. We are using 70% data for training and 30% data for testing. In this cell, we are giving the data to KNN library, KNN model, and we are getting the accuracy as 92%. It is very good accuracy comparatively. And next model is decision tree. We are applying the same data to decision tree also, and it is giving accuracy of 95%. And all this F1 score recall are very much higher comparatively to KNN. And next one is logistic regression. We are applying the same data to logistic regression also. We are getting the output of accuracy as 83%. Then next one is random forest. We are getting 97%, which is highest among all the algorithms. And the very last one is XGBoost. We are getting output accuracy of 96%. Now, what happened here is after applying all the data pre-processing steps, I applied 5 algorithms. Uh, to be precise, they are classifiers to the data set, and we are getting few accuracies. They are comparatively very high since we data pre-processing data. And then what we'll be doing in the next step is let's try to compare all the models first. As you can see, KNN has accuracy of 92, whereas decision tree 95. Among all the models, yes, we can see here, random forest has performed very well. It has 97% accuracy, and logistic regression has the least accuracy among all, that is 83%. As you can see, even all the in the recall in F1 score and also in the precision, random forest outperformed all the other algorithms since because it's an ensemble method, it will be getting very high accuracies. Let's discuss regarding this in further. In the very next step, let's start our main goal, that is hybrid feature selection approach. What I'll be doing here is I'll be first applying low variance filter to the data set, and then for the data set, I'll be applying PCA and I'll be capturing the top 5 most important features, and we should actually call them as components. So as you can see here, first I applied, as you can see here, actually there are 13 columns in the data set, excluding ID, we'll be having 12 columns. We are using a threshold of 0.01 for variance. After applying variance, we'll be applying PCA to the same data set. What happened here is originally there are 13 columns. After applying low variance filter with threshold 0.01, we still gain 12 features, and then we applied PCA. with n components as 5. So we'll be getting the top 5 n components, which has the maximum variance. So now we have selected features which are very important, which has the highest variance. Now let's reapply the machine learning models again, and then let's compare what is happening before feature selection or after feature selection. So here I wrote all this code in single block. What I am doing here is I'm reapplying all the machine learning algorithms which I used previously, like KNN, decision tree, linear regression, random forest, and XGBoost to the data which passed through hybrid feature selection. So I'll be applying regarding the models, and I will be evaluating using the same evaluation metrics, that is accuracy, precision, recall, and F1 score. I'm applying the models, and then we are comparing. Now here is the result. After applying hybrid feature selection to the same data set, we got the result like this. KNN is again performing 91%, decision tree 93, logistic regression 77, and random forest plus 96. XGBoost with the accuracy of 92 after hybrid feature selection. Now let's try to compare them visually. As you all can see here, I hope it is visible. Yeah, you can see here the blue lines represent before feature selection, whereas the red lines represent after feature selection. What happened here is the KNN almost maintained the accuracy. Decision tree was dropped a little. Logic regression was dropped few after hybrid feature selection. Random forest actually is the most important algorithm for us because it performed very well. It's having an accuracy of 97% to be precise before feature selection. But even after feature selection, it regained its accuracy, but just lost 0.9% of the accuracy. That is very good comparatively to all other algorithms. And the XGBoost performed 96%. After hybrid feature selection, it was 92.5%. So what happened here is we have successfully applied a hybrid feature selection by maintaining the most important features. We got the better accuracies, and the accuracies were not much decreased. So as you all can see here, this is an average matrices before feature selection and after feature selection. So the average accuracy before feature selection among all the models is 92.9%, and after feature selection it is 90.37%. And at the last step, we'll be experimenting with one another concept. What we have done before is in hybrid feature selection, we have applied low variance filter, and then we have captured top 5 most important components. But what if we increase the components? If we increase from 5 to 7 and 9, so now let's see. What I'm doing here is instead of only going for the top 5 most important features, I'll be experimenting with the top 7 features and top 9 features also, and then let's compare them again. As you all can see the here code, I'm experimenting with the 23 values of n components 5, 7, and 9, and again applying the same models and again with the same evaluation matrices. You can see here we are in the output, we are evaluating with n components is equals to 5, n components is equals to 7, and n components is equals to 8. And here comes the output of comparison of all other models for various n components. As you can see, KNN for n component is equals to 5, it is 91.7. With n component is equals to 7, it is 91.9. And with n component is equals to 9, it is 92.36. We can clearly observe an increase in accuracy, which we can easily tell that the KNN model is very much prone to very much sensitive to hybrid feature selection. So feature selection should be very precise in terms of KNN, whereas our random forest is the most performed algorithm in our code, where it is for n component is equals to 5, it is giving 94.6%, where for n component is equal to 7, 96.5, and for n component is equals to 9, 96.4. One thing which we clearly observed is it is continuously increasing with the increase in components. Even with the decreasing components, also it is giving the better accuracy compared to all other codes. So what we can what we can get the conclusion from this project is we got an a hybrid feature selection approach code where we got an accuracy of 97% for the random forest. So we will be creating very good model for using random forest. And also we saw the importance of data preprocessing using some of the techniques like SMOTE, and we are handling the outliers and handling missing values. So I think this is the end of the video. I'll be providing the link for the dataset, and I wrote a clear medium blog. I'll be providing the link for the blog in the description. I'll be providing the link for the code in a GitHub link in the description, and I'll also be providing the link for dataset in the description. Thank you for watching this video.